Where are we? There we go. So my name's James. I'm the lead web developer at a startup out of Balaclava called Header. And what we do is we build software to help people make choices in their lifestyle that's going to enhance their health and well-being. So when I'm not at Head Up Labs, working away, writing code and building great features, I'm probably playing PUBG. And if you only take one thing away from this talk, it's that I've probably killed you in the game. And what I'm not an MVP. I'm not an exhaustive expert on Azure Functions. What I'm going to walk through is my experience over the last 4 months, what we've applied Azure Functions to, what went well with it, what didn't go so well with it, how we managed to continuously deploy it, which has been cumbersome if you're just starting out with it. So that's that's kind of the limits of what I'm going to go through. So don't think that I know everything. There's guys out here probably look at what I will say and hey, why don't you try to do it this way? And that's perfect. Everyone learns from that. A little bit more about Head Up. We've got a beautiful office down in Balaclava. Obviously, heaps of empty desks. They're all sit-stand desks, so it's a fantastic office. We've got a team of 8 people, made up of the founders, creatives, obviously a couple of developers, designers, and data scientists. And what do we do? And I just wanted to explain that just to kind of colour the rest of the talk around how we apply Azure Functions. Is basically we take biometric information and we combine it with self-reported mood data and activity data to help guide people in the lifestyle decisions they make so that they can have a greater level of health and greater level of well-being. So a bit of an overview. What's Azure Functions, for those that haven't used it? What's the Head Up experience been using Azure Functions? What went well and not so well, a bit of a recruitment plug, and then time for questions at the end. So what is Azure Functions? In summary, basically, if you have a very cohesive problem that you want to solve, you want to develop a very focused solution, then you write a small piece of code and deploy it into Azure, and then Azure are responsible for provisioning the infrastructure for that code to run on. It's ideal for processing data, whether on a schedule or driven from a queue or some other event in Azure. And one of the 2 great benefits is, one, you trust Azure to scale it correctly. Use the word trust lightly, which I'll explain later. And you pay only for the time your code runs. So rather than having a dedicated server and you get charged by the hour, it's charged based on memory consumption and the time that it took to run, which is fantastic, which I'll show later on. So our experience, what were we trying to build? Essentially, we were trying to create a Fitbit data collection engine. So our users would come along, they'd sign up, they connect their Fitbit account, and then based on a queue system, pub sub system, we pull their data in, which was great because we didn't really know how much traffic we were going to get from this thing, like how often would Fitbit prompt us, how big would the payload be, how much time would it take. And also just in general, we wanted to separate offline processing from back-to-back interactions with the user so that we weren't conflating the needs of those into one system and overwhelming the back end and upsetting our users. So we started playing around with it December, late November maybe, and then leading into our app closed early access launch, it kind of looked a bit like that. It wasn't fantastic in January. We had a lot of learnings from it. Not it was the benefit of separating it from what the user experienced was we didn't really have any bad knock-on effects on our users because it was all happening in the background. But we learned a lot about managing the concurrency of infrastructure, setting timeouts, being judicious with your use of wrapping up the function's execution. And then when we got to February, it looked a little bit more like this. I was going to actually put a picture of all of these failing with a 5-minute duration on all of them, which happened a lot, but I actually couldn't find any, so I just put that stupid picture of the dude on the water slide in.
What are we looking at there? Sorry, I'm not that familiar with this.
So this is just a bit from the Azure Portal, which is looking at our Fitbit data collection function, and that's showing all of the runs that it's done, how long it took to run, what invoked it, so this is a queue message, and then obviously just how many times it's run and how many times it failed. Sorry, if you have any questions, just pull me up. Otherwise, I'll just keep going. If you wanted to start out with functions, you might, start Googling, find yourself on docs.microsoft.com, and you'll come across something like this, which is taken from their intro page about, hey, learn how to do functions. And their first example is create a HTTP-driven function. And what you end up creating is something that will take something off a query string and print it back out at you. And you're like, you go into Azure Portal, you click some buttons, you create it, the code comes out, you run it. Awesome, right? And then you go, well, how do I locally edit that? And how do I get it from my local machine into Azure? Because I don't want to live inside of a Node web app to edit all my code. That's insane. Like, I've had this basic affordance for years now where I've been able to open an IDE, make some changes, commit it, and make it so with CI. And then stepping even further beyond a really basic function like a HTTP function, we have queues, and maybe your function pulls data in from a database and looks at an API. Well, like, I can't run that locally even with Azure Functions CLI because it just doesn't support providing those pieces of data at runtime when it's on my machine. It just doesn't work. So where do you go from here? Pretty much all the things I just said. How can I get it from being in the Azure portal to being in an IDE, and then I change it, I commit it, and it just make it so? Well, there's some examples on docs.microsoft.com again that you look at and you try them, you waste your time, and then they kind of work, but then the package on your machine looks different than the package in Azure, and maybe I want to use Node, maybe I want to use C#. How do I do per environment configuration? You know, my connection string in development is different than my one in production. It just doesn't work. So peeled it back, and I just peeled it back to the basics, found some other information that said using ARM or Azure Resource Management is a really great idea, along with continuous deployment like TFS or VSDs, and then some cheeky stuff that hopefully I can remove soon. So is anyone, hands up if you've used Azure Resource Manager? Oh, that's great. Okay, cool. Sorry. So you can use Azure Resource Manager to provision a functions app, which is just a collection of functions that runs in Azure. And by using ARM, you can tell it, in this environment, I want you to use these kinds of connection strings, or I want you to use these kinds of app settings. And by doing that, you can actually set up per environment configuration. And obviously, because it's an ARM template, you can version control it. So we've already won half the battle, going from the portal to being able to version control our environment and our code along with it as well. And then obviously VSTS to do all our continuous deployment. So executing the ARM scripts, copying the function code into our storage account, and then obviously if you're using Node, you'll want to run npm install to get all your packages there. So with that said, I'm actually going to go through and do a demo, and hopefully it all works. I've actually got to make a couple of changes, so I'll show you how that works. I might actually just duplicate so you can see what's going on. So this is one of our Azure functions. It's a Node function, so we just have and it's a function that's exposed as a module to other components, but needless to say, it runs in the Azure Functions context. It takes a queue item, queries Fitbit, pulls out some exercise data, and stores it in a database for us. So we're just going to make some small changes to one of these. Is it in sleep? I think it's in sleep. Maybe it's in... No, it's in the client. So I don't really need any of this stuff. I did some work today where I don't need this anymore. Okay. I'll just get rid of that. And I'm also missing a context.done call. So I'll just put that in. Context.done is, especially if you're using ES6 promises, which is like your asynchronous mechanism in ES6, something you need to be pretty judicious about, because obviously the promise will just kick off and it'll instantly return control back, and if you don't have a context.done in the callback for the promise, it'll just like shit itself and run till timeout, basically. So one of those minor learnings. I'm just going to go ahead and commit that, and all good.
So can you run that locally?
This I can, yeah. So for the node-based function, to give myself some... Sorry, where'd the question come from? Sorry. To give myself some confidence when I'm extending this collection of functions, so like I wanted to start collecting sleep data, what I did was I basically mocked out all of the fetch requests that the function could expect to execute, and then structured the function so that I could call the guts of it like any other JavaScript function. So down in the console, I can basically run it like any other Node application. and it'll run through and provide all the data packs match up, then it'll give me some confidence that I'm not accessing any potentially undefined attributes or anything that's null or potentially not there. So it gives me some confidence. Like you could sit there and unit test it and mock it out to the nth degree, but you're kind of starting to remove yourself from the practicality of it running in the real environment. So you can only give yourself a certain degree of confidence, and then you need to start putting it into the development functions app and running it and seeing what it's doing.
So there is no way to run the function as it would run on the cloud environment?
As in Node, like you can treat it like any JavaScript function. So if I were to show you the signature for one of the mocks in here, so basically just mock out all of the potential responses to any fetch request that it will make, and then use an npm fetch mock library to say, hey, when you call Fitbit API, instead of actually going to the API, just return this payload instead. And then the guts of your function will still run as though it in the Azure Functions context. You basically just need to inject all of your dependencies, if you will, into the function for it to be mocked out effectively. The more you mock it out, the more confidence you're going to get, but at some point you need to put it in there and run it.
There's no like emulator or anything like that for the Node?
Yeah, there's a Node package called Azure Functions CLI, and that supports obviously HTTP triggers.
Yeah.
Is it'll just run it on Node and then listen on HTTP.
Right.
But it's pretty limited, like it doesn't inject queue items or anything like that. So one strategy I ended up going with was exposing the guts of the function and allowing it to accept an argument of the queue item, and then just mocking out the queue item and passing it in. You get it as close as you can, basically, yeah. And I'm sure with C# you could start writing your own unit tests with unit testing libraries that you're more familiar with. So let's commit that. Yeah, this one. Retry. Okay. So once I push this, go over to VSTS and see what it does. That's not the one. There we go. So that's kicked off a build now. While that's building, I'll show you what the steps it takes, and then walk through what went really well with my experience with it and what didn't go so well. In terms of the actual steps that this guy will do, let's go. So obviously it's going to download all the artifacts and do all the stuff you expect TFS to do. Then it'll run the ARM template, and when it runs the ARM template, it'll look at the environment that it's targeting, and it'll apply the appropriate connection strings and app settings. Once it's done that, it'll run npm install, which will just pull all of the Node packages in, and then this is where everyone's hacked something to get it to work, and I feel like this is the hack I've done to get this to work, but it's to use net, which is you can manage the network status on the build agent. So using that, you can mount your storage file share to the build agent, and then, because ultimately your functions code actually physically resides in a storage account in Azure. So you just push all that stuff into the storage account, and then you restart the app service, and Bob's your uncle, or your auntie. So let's just get this extending again.
Did you choose to use Node for any particular reason?
Initially I wanted, because we're a new company and we're testing out new technology, so I wanted to have one that was C# and then one that was Node based. And what I found was that I kind of preferred using Node because you could have deeper data structures in terms of the data coming into the function. So let's say you've got a database record that comes into the function and then you manipulate it and you put it back out. That was actually a lot easier to do with Node than it was with C#, because in C# or CSX, I should say, the C# scripts, you have to make a choice to create a class for the data types coming into the function, or you rely on Newtonsoft to deserialize the data for you effectively. And when you do that, you need to deal with like the JObject, JValue API, and the getters and setters for that are just a pain in the ass to deal with.
You can also use Dynamics, right?
You can use Dynamics, yeah. So
So you gained that, but you also lost what all the benefits of compiled functions.
yeah, absolutely, yeah. But that's the benefit, right? Like you accept that you can deal with arbitrary data sets more easily because you're not relying on establishing a static type. So that's the compromise, yeah. Where are we? Okay. So what I'd do differently with that CI setup is I'd look for a better VSTS task to transfer the files to my file share in my storage account. It was probably about 4 months ago since I set that up. So, I mean, I know that a lot of the task handlers get written fairly frequently. There's new versions coming out all the time. So
The Azure web app deployment task will do it. You can basically point it at a folder.
yeah.
Publish it to a function.
And that's one of the paths I went down initially. And at the time, I can't remember why, because it was like 4 months ago. I just couldn't get it to work. Yeah. I know there's also like a file copy for a storage account task, but I couldn't get that to work either. But like I said, that's, you know, I want to keep, like, if I find a better one, then yeah, I'll definitely change those last 2 steps out for something better. And of course, get the web server itself to run npm install. I've heard that, you know, if you put package JSON in the root of the function app, Azure is smart enough to just go, hey, you're trying to install node modules, so I'll just do it for you. And that would reduce the build duration probably by like 3 or 4 minutes, because we all know as soon as you install one npm package, you install the whole internet. So that's probably what I'd like to do. So what worked well? The money. So I did a quick look at, and like the reason there's gaps in the days is because some of those days, like, it literally just didn't cost us anything to run it. There's sort of a threshold at which point Microsoft charge you, and it's based on usage. So there were some days where we didn't even get charged at all. And just looking at like the user count we have, you know, it would basically take 120,000 device connections before it even costs us $1 to run this for the better part of a month, which is insane. You know, contrast that to paying $100 and something for a standard server and dedicated server, and maybe it's not getting used as effective as it could be either. So that went really well. What worked really well, and unfortunately I took this out today out of it because we changed our integration a bit, we just didn't need it anymore, was interfunction comms, so using queues to relay messages between functions. So because we were using OAuth to talk to Fitbit, obviously OAuth tokens expire, you need to renew OAuth tokens, so we split that off into a separate function and used a queue to say, hey, this user needs to have it refreshed, so do it in a separate function. And you can kind of tell, like, when you look at the invocation details, that obviously Microsoft had this very much in mind, that people would be doing this, because there's like a extra field in it that says which job it came from and went to. So that worked really, really well, but like I said, we took it out. What didn't work so well? The scale controller. It gets it right. The scale controller is the component that determines how much scale your function app should have. So it'll look at how long does it take to get through an activity, in how long does it take to run the function, and then the rate at which items are being added to the queue. And based on those two things, it'll scale out and add a number of instances. But I found it was a little bit too aggressive. So if we had a user whose OAuth token was expired and then suddenly they decided to track their sleep and then we found out about it, we'd get their sleep and there's a chance the scale controller would spin up like 5 instances. And then because the access token was expired, it hit Fitbit 5 times for a new access token, and then we would be locked out of their account basically, which didn't help. Also doesn't help that Fitbit's like really tight on their OAuth implementation. So to get around this, we basically, and this is temporary, obviously we're going to have to increase this at some point, but this will basically make it so that it takes at least 1 item on the queue to kick off the function, and it will consume 1 item at a time. So it's just doing 1 by 1 by 1 by 1, which is fine for now. We really don't have enough requests to warrant increasing that. Consumption plans going cold. So when you roll your own function app, you can make it dedicated or consumption-based. Obviously, we wanted to go with consumption-based because you don't get any benefit of the cost savings if you go dedicated. And obviously, those things can go cold. So most of our users are... Sorry?
Can you explain that whole aspect a bit more?
Yeah, absolutely. So when you start it up, you go, I want to create a Functions app, and it'll go, well, do you want to make it dedicated? Which in essence means it's pretty much exactly the same as rolling your own app service. It's a dedicated environment. It will always be on. and you get charged the same as you would otherwise, so you get charged per hour that it's turned on. As opposed to consumption, which is you just kind of put your code into Azure, and then they are responsible for provisioning a VM that it will run on, and then when your code's done, they'll turn that VM off for you. So you get charged based on usage. It's like a combination of memory consumption and runtime, as opposed to hours that the server is running. You get the huge cost saving, which I showed, but also it can go cold. So we had a lot of Australian users, and overnight, no one syncs their Fitbit overnight. It just kind of sits there while they're sleeping. So all the app services went cold, and when they'd all wake up, all their sleep records would start coming in, and then Fitbit would be going, hey, there's sleep data. And they have an SLA that says you have to respond within 5 seconds to our pub sub, or we'll basically turn it off. And the whole warm-up process was taking like 15 seconds. So we instead of putting on a dedicated server, we took the polling part of the function out and put it onto our API that runs on a dedicated server. And then it would just basically take that and then put it on a queue, which was a better implementation anyway. So you don't always have to flip it over to dedicated.
I'm not sure how it works in Node, but in C# you can have another function within the function app. You keep pinging it,
Yeah,
and then the whole function app
stays warm. Yeah. The other reason that kind of made me want to put it all in our API that runs on a dedicated server anyway was you can do signature verification and more security stuff before the queue message actually goes into the function. So it wasn't just performance or keeping it warm that led to that decision. Yeah.
How does Fitbit users link up to your apps?
So Fitbit have a RESTful API, and it's like, you know, when you log into a system using your Facebook account, you click on it and then it goes, hey, Facebook wants to access, this app wants to access your Facebook account, and you go yes, and then Facebook will get access to, the app will get access to your Facebook data. It's a similar relationship with Fitbit, so users will come into our site, and then they'll go, oh yeah, I want to connect my Fitbit. They'll get presented a page that says, HeadUp's trying to access this data, do you allow it? And you go yes. And then we get a no-auth token to access your Fitbit account, but also we add a bunch of subscriptions. So when the user's Fitbit syncs with their phone, that goes to Fitbit's backend, and then Fitbit send us a notification that, hey, there's new data, you should query us for that data. Yeah. Coming back to this note, it's kind of related to the next slide, is just coding defensively. So a couple of strategies was obviously not relying on the default timeout of 5 minutes, which maybe tongue-in-cheek Microsoft have kind of said, hey, 5 minutes, yeah, they can let their functions run for 5 minutes if they want, because it's all-based on how long it takes to run. But don't rely on that default timeout. Set it to something responsible. Don't set it too low, because if your consumption app goes cold, it might take longer than you think to warm up. So give it some time to warm up, but obviously don't rely on the default 5 minutes. And use context.done judiciously, because again, if you don't put, in Node in particular, if you don't have a context.done in a certain place, it could end up running until it hits your timeout. I didn't really touch too much on the way bindings work, but essentially, if I come back to the portal, maybe I can show you. Where are we? Of course. So you can, with each function, you can essentially bind different bits of infrastructure in your environment to it. So they end up looking a little bit like this. So you can have your inputs, which could be a database record, and your outputs, which could be more queue items or more records for table storage, or again, database, and then obviously your triggers. So the big ones in there are the Cosmos DB, Document DB, and then table storage. What I found is that some bindings were a bit limited, so the runtime will provide you with like a library to use that binding, and some of it isn't fully fleshed out. So table storage binding doesn't support upserts at all, which is fine. Like you can, if you're running a node, you can just install the npm package and then use it to do what you were otherwise trying to do. And then again with the CSX script, you can just do a load require statement. Yeah, that's pretty much it. I'm going to cheekily do a little plug. We're hiring, Head Up Labs is hiring a great back-end, front-end developer. So if this at all sounds interesting to you, or any of this technology resonates with you, or what we're doing resonates with you, then just let me know, and this could be you. But otherwise, check us out on social media. We're on all of the regular social media platforms. Any more questions?
You have any sample of what you are providing to the users? Like a dashboard or something like that we could see?
Sure, of course. So, this is one of the common processes our users go through, and this is the self-reporting process. So they log in and they go, I felt like this, or I did this today. I don't think this account's loaded up with any messages that we give them at the end. That's okay. This is all written in React as well. They'll let us know what they did. And then they'll either get some kind of call to action to go and check out our social media, or they'll get a personalized lifestyle insight. And this is like our early access closed application where we're testing ideas out. We've only just started working on our React Native app. Cool degree, Joe.
You had that really cool list of your costs of a few cents per day,
Yeah.
which is a great story. When you were in that phase earlier of there being problems and your functions, you didn't have your context stop done and your functions were running for 5 minutes, how bad did the costs get? 'Cause that's what's kind of scared
I'll
me off
tell a
of
story,
using
you'll laugh
consumption.
about it. I don't know if everyone else will, but you'll laugh.
Yeah.
It was not that bad. So halfway through the development, we decided we'd add a created date field to all of our users, and that's seeded to the 1st of January 01 AD. And we had a routine that said when the user logs in, if their Fitbit needs to be reconnected and resynced, either use the last sync date or the created date. And we had some users who'd gone halfway through onboarding and then left and then come back, and halfway through onboarding and gone, and those users end up creating several 100,000 queue items. App Insight sent me an email that, oh shit, your function's doing way more than it's normally doing. What's going on here? And then I looked at the user that was doing it, and it was Tobias. Yeah, he's good at DDoSing people in an indirect way. But essentially on that day, it was late January, I think it was $5. Yeah. So I didn't feel so bad about it. Yeah.
Send him the bill anyway.
I will. Yeah. He'll probably send me some of his brewed beer. Yeah.
Passwords and usernames within the function and accessing.
Oh, yeah. That's I completely skipped over that. So I'll give you a glance. So this is an ARM template. This is the ARM template that we use to version control and deploy the infrastructure. And because it's just a app server in Azure, it accepts app settings. So you can write the template the way you would write any other ARM template by providing these app settings. So you got things like your storage connection string, or where the content for the website gets held, a whole bunch of other settings in there. And obviously those are all parameterized by the ARM template. So over here I've got development.parameters.json and production.parameters.json, where all of the keys live. I won't be clicking on that. I've already revealed enough. And that'll get run by VSDs, and it'll inject all of those into the app service. But then, of course, you've got to access them as environment variables inside the function. So one instance of that is over in here, I think. For Node, it's process.env, and then the key is the app setting. I think in C#, you've got, it's just a helper function, I think, for the environment variable. Does that answer your question? Cool. Sure.
at least in the C# side of things, is it something that you can attach a debugger to? Mid-function something?
So I believe that you can if it's HTTP triggered with the Azure Function CLI, which is just a node package. So if you Google Azure Function CLI, you get some instructions to install a package, and then it gives you a bunch of commands you can run. If you wanted to have other functions that were maybe driven by like a queue or anything like that, then you could probably write a separate C# script to call it like you would any other method and inject it with the parameters it requires. So I look at this.
With the latest CLI, now you can have the C# function, you can employ queue, have breakpoints, and then you will tell the latest CLI.
Yeah. There's also a set of HTTP triggers to trigger off those non-standard items. So basically administrative controls to emulate if there was something in the queue, if there was something in Event Hub, if there was a document DB change. So there's a separate admin control to get to those endpoints.
Awesome, thank you. Yeah. Any other questions? That's it? All right, well, thank you very much. I won't get in the way of pizza. It's just rocked up. Appreciate all your time.